Tonight, the night sky holds its breath. Above us, far beyond the reach of satellites and ordinary telescopes, an interstellar visitor streaks silently through the void. Astronomers call it 3I Atlas, the third confirmed object to cross into our solar system from another star. But this one does not behave like the rest. Instead of fading into the cold background of space, it flickers, it pulses, and it glows with an eerie green hue that no one can fully explain. This is not just another comet. Every signal, every observation seems to suggest something stranger. Patterns emerge where there should be chaos. Light bends and brightens as though controlled by an unseen hand. Its trajectory connects dots across the solar system that no natural rock should ever follow. So, tonight, as new data streams in, the world is left with a question bigger than science alone. Are we simply watching a frozen relic from a distant system, or are we witnessing the first engineered object to wander between the stars? For the first time, humanity may be standing on the edge of a discovery that changes everything. When 3I Atlas was first spotted, it did not look like the kind of comet astronomers expected to find. The discovery came from faint, scattered images deep in archival sky surveys. Instead of appearing as a dusty streak or a fuzzy ball of ice, it revealed itself as a sharp point of light that seemed to grow stronger with each passing night. Almost immediately, its color raised alarms. Most comets glow a soft white or bluish haze, but Atlas shone with an intense green that cut across the darkness like a neon beacon. At first, researchers thought the glow could be explained by cyanogen gas or diatomic carbon, molecules known to emit green light when energized by the sun. But the spectrum of Atlas refused to match what chemistry predicted. The shade was off, too vibrant, too sustained, as though it were being driven by a steady power source rather than random outgassing. Then came the light curve. Instead of dimming and brightening in the gradual rhythm of sunlight hitting a rotating comet, Atlas flashed in uneven intervals. To some, it looked almost biological, like the shallow breaths of a creature fighting to stay alive. Others compared it to a machine, a pulse timed to hidden gears. Night after night, telescopes recorded this strange heartbeat, and every time the data came back, it seemed to mock the idea that this was just a lump of ice. All the while, the questions piled up. Why does the trajectory not align with the physics of natural debris? Why does the glow not match any known comet chemistry? And why does the flickering light seem to follow no pattern we can explain, yet too regular to dismiss as random? To the scientific community, the early signs of 3I Atlas were not answers. They were puzzles, and each puzzle pointed toward the same unsettling truth. Something about this visitor does not belong to the universe we thought we knew. By the time 3I Atlas had crossed the orbit of Jupiter, the debate among scientists had already become heated. Every fresh observation seemed to deepen the mystery rather than solve it. To make sense of this strange visitor, researchers pointed to 3 major anomalies, 3 signs that continue to defy easy explanation. The first was its trajectory. Unlike Oumuamua, the cigar-shaped rock that whipped past Earth in 2017, or Borisov, the icy wanderer from 2019, Atlas traced a path that looked almost scripted. It was not just passing through. Its curve bent in ways that seemed too precise, threading past Mars, dipping behind the Sun, skimming Earth's orbit, and then setting course toward Jupiter's magnetosphere. Natural comets follow gravitational pulls and solar winds. They do not appear to connect dots across the solar system like a traveler following a map. Some astrophysicists insisted it was coincidence, the product of orbital mechanics and luck. Others admitted quietly that the odds of such a neat trajectory were staggeringly low. The second anomaly was its light. Most comets scatter sunlight chaotically, their brightness rising and falling as their jets of gas sputter into space. Atlas, however, blinked in intervals. Data from telescopes in Hawaii, Chile, and Spain showed that its brightness would suddenly flare, then drop, then flare again. Not in random bursts, but in patterns that looked suspiciously regular. One group of astronomers compared it to a beacon, a signal that seemed almost deliberate. Another group countered, saying that complex outgassing could mimic such behavior, especially if volatile ices were buried in layers beneath the surface. But when the timing of those pulses lined up with hours rather than days, the explanation began to feel thin. The third and perhaps most unsettling anomaly lay in its chemistry. Spectrographs revealed traces of molecules that did not quite belong. Yes, there were the usual suspects: carbon, oxygen, a sprinkle of cyanogen, but superimposed were faint lines in the spectrum that matched no common cometary material. Some argued the readings were errors, artifacts of the instruments. Yet the same results appeared across different observatories, separated by oceans, using different equipment. A few scientists dared to whisper the unthinkable. What if the spectrum was showing alloys, metals refined rather than formed naturally? What if the green glow was not the product of simple chemistry, but something more exotic? Mainstream researchers pushed back. The European Southern Observatory issued a statement calling the anomalies interesting, but not outside the range of natural variation. NASA suggested that sunlight scattering off dust grains could explain the unusual brightness. These official lines reassured the public, but within academic circles the tension was clear. For every paper that explained away the mysteries, another emerged that insisted the data pointed elsewhere. On one side stood the cautious voices, arguing that extraordinary claims require extraordinary evidence. On the other side stood those who could not shake the feeling that Atlas was rewriting the rules of interstellar debris. And so, the comet, or whatever it may be, became more than an astronomical object. It became a mirror reflecting our limits, our doubts, our hunger to know whether we are alone. Scientists stared at graphs and data streams and saw not just numbers, but hints of something that could shatter centuries of assumptions. Tonight, as Atlas sweeps closer, those three anomalies, its precise trajectory, its pulsing light, and its puzzling chemistry, hang like questions written across the sky. Questions with no easy answer, and consequences far greater than any single observation can hold. As the sun dipped below the horizon this evening, telescopes across the world turned toward the same target. From the deserts of Chile to the volcanic peaks of Hawaii, from small amateur observatories and backyards to the great eyes of NASA, every lens pointed at one thing: 3I Atlas. Tonight marks the moment when its orbit carries it behind the sun's corona and out the other side, a maneuver that no ordinary comet should survive in one piece. If Atlas emerges intact, glowing brighter than ever, the implications will be staggering. For astronomers, this night is more than just an observation. It is a test of physics, of technology, and of trust. All of the data that will stream down in the next few hours, spectral readings, brightness curves, magnetic field measurements, will be captured first by NASA's solar probes and Earth-based telescopes. And that means, at least at the start, the knowledge belongs to a handful of institutions. That fact alone stirs unease. If Atlas truly reveals something unprecedented, will the world know at once? Or will the data be filtered, studied, even withheld before the public ever hears about it? Tonight, the gatekeepers of truth are not philosophers or journalists, but servers deep inside NASA facilities, where the raw numbers arrive in silent streams. And yet, outside those walls, the sense of anticipation is impossible to ignore. On astronomy forums, volunteers set up live streams, hoping to catch even the faintest flicker. Amateur astronomers configure their rigs to snap automated images every minute. Radio enthusiasts listen for static in unusual frequencies, convinced that Atlas might be whispering across the cosmic void. What makes this night so important is not just the data itself, but what the data represents. If the green glow shifts in intensity, if the pulses of light fall into a regular rhythm, if the trajectory bends in ways unexplainable by gravity, then the questions scientists have tiptoed around will crash into the open. What if this is not a natural visitor at all? What if its behavior is engineered? For NASA, this night is a delicate balance. On one hand, the agency must provide calm, careful explanations. On the other, they cannot deny the anomalies that thousands of independent observers are already recording. If something extraordinary happens, if Atlas flares in a way that no comet should, then the story will not belong to NASA alone. It will belong to the entire human race, watching together in real time. And so, tonight carries a tension unlike any other astronomical event. When comets pass, we marvel at their tails. When asteroids skim by, we note their danger. But when an interstellar object crosses into our skies carrying mysteries we cannot solve, we are no longer passive spectators. We are witnesses to a moment that could redefine our place in the universe. Somewhere right now, hidden behind the glare of the sun, Atlas is revealing its next move, and when it emerges, intact or shattered, brighter or darker, ordinary or extraordinary, the world will be waiting. As scientists wait for Atlas to reappear from behind the sun, the possibilities narrow into three starkly different futures. Each one carries its own weight, its own consequences, and its own story for humanity to wrestle with. The first scenario is the safe one, the explanation that keeps our universe predictable. In this version, Atlas emerges just as a comet should. Perhaps its green glow fades as volatile ices burn off. Perhaps its flickering stabilizes into the random brightness curves astronomers expect from dusty jets. Its orbit, while unusual, might ultimately bend and stretch in ways that can still be explained with careful equations. If this happens, scientists will breathe a sigh of relief. The mystery will shrink back into the category of rare but natural. We will adjust our textbooks, refine our comet models, and move on. To the public, the story will be a curiosity, fascinating but not earth-shattering. Atlas will be remembered as another oddball visitor, strange but still belonging to the realm of ice and stone. The second scenario is more dangerous. In this path, Atlas begins to misbehave in ways that threaten not only scientific certainty, but also earthly safety. What if it fragments unexpectedly, sending debris through orbital lanes where satellites circle the planet? What if its chemical composition includes compounds that react violently when exposed to solar radiation, producing bursts of energy far stronger than predicted? Or, most unsettling, what if its trajectory shifts after the solar pass, placing it on a collision course, not with Earth directly, but with regions of the solar system where gravitational slingshots could one day redirect it toward us? Even a small chance of impact carries global implications. Governments would be forced to plan, militaries might mobilize, and suddenly a distant visitor would become a looming threat. In this scenario, Atlas would move from a curiosity of science to a problem of survival. And then comes the third scenario. The most extreme, the one whispered about in late-night forums and hinted at in cautious scientific papers. In this version, Atlas does something no natural object ever should. Its pulses of light shift into a steady rhythm, like the ticking of a clock. Its trajectory alters in defiance of gravity, nudging itself into a path that looks less like a random drift and more like a course correction. Instruments detect emissions, radio bursts, microwave beams, or radiation signatures that do not belong to chemistry or physics as we know them. If such signals emerge, the unthinkable question will no longer be avoidable. Is Atlas engineered? In that scenario, the implications stretch far beyond astronomy. If Atlas is artificial, then it is evidence, not speculation, not myth, not rumor, of technology built by intelligence beyond Earth. That would mean we are no longer the only storytellers in the cosmos. For some, it would be exhilarating, proof that we are part of a larger community of minds. For others, it would be terrifying, because any intelligence capable of sending a craft across interstellar space is, by definition, far more advanced than us. Yet, even within this extreme scenario, shades exist. Perhaps Atlas is not active, but ancient. An artifact launched thousands or millions of years ago, drifting until it crossed our sun. Perhaps its signals are not messages, but residual functions, like a machine still humming, long after its builders are gone. Or perhaps, though this is the most unsettling possibility of all, it is not merely drifting, but observing, watching us as intently as we watch it. Each of these three futures, natural, dangerous, engineered, carries profound consequences. The safe scenario preserves our comfort. The dangerous one forces us to prepare. The extreme one shatters the boundary between human history and cosmic history. Tonight, as the data streams in, the world does not yet know which path awaits. But one thing is certain. By dawn, the mystery of Atlas will either grow deeper or transform into revelation. If 3i Atlas turns out to be nothing more than an exotic comet, the world may move on quickly, chalking it up as another strange but natural curiosity. But if even one of the unusual signs proves to be more than coincidence, if its flickers hold rhythm, if its chemistry hints at something manufactured, if its orbit appears guided, then the consequences will ripple far beyond tonight. The long-term impact would reach not just science, but politics, philosophy, and even the way ordinary people look at the night sky. The first and most immediate consequence lies in research. Entire fields of astronomy and planetary science would pivot. Billions of dollars could be poured into new telescopes, deeper sky surveys, and faster probes. The question would no longer be whether life exists elsewhere, but how soon we might find it again. Every interstellar rock, every faint signal from deep space would be treated as a potential artifact. What was once considered fringe science would become mainstream. Then comes the issue of control. Who owns the truth about Atlas? If NASA, the European Space Agency, or China's observatories confirm anomalies that suggest something engineered, will the data be shared openly with the world or held closely as a national security asset? Already, debates smolder over who has the right to analyze and distribute cosmic knowledge. A discovery of intelligence beyond Earth would heighten those tensions. One nation's transparency could be another's vulnerability. Beyond politics, there are ethical questions. If Atlas is artificial, what do we owe to the builders, whether they are alive, extinct, or something in between? Do we treat such an object as an artifact to be preserved, like a museum piece of the universe, or as a resource to be mined for technology? Humanity has never been good at resisting the urge to dissect what it does not understand. Yet, tampering with something that has crossed the stars might raise consequences we cannot yet imagine. And then there is the philosophical weight. Religion, culture, and identity would all feel the tremors. For centuries, we have told ourselves stories about being alone or being chosen. A single engineered object, drifting silently past our sun, could shatter that narrative in an instant. Some would see hope in it, proof that we are not the only dreamers in the cosmos. Others would see fear, a reminder of how small and vulnerable we are. Even if Atlas proves harmless, even if it sails away into the darkness never to return, the questions it raises will linger. Our textbooks would change, our expectations would shift, and every time a new dot of light appears on the sky surveys of tomorrow, astronomers will ask not only, is it a comet, but also, is it watching us? The truth is simple. After Atlas, humanity will not look at interstellar space the same way again. Behind every chart, every graph, and every official press release about 3i Atlas are human beings. Ordinary people staying awake through extraordinary nights. Inside NASA's control rooms, engineers hunch over glowing monitors, sipping cold coffee as they track numbers that might rewrite history. Some are veterans who have seen dozens of comets come and go, their faces calm, but their eyes betraying anticipation. Others are young interns, experiencing their first major event, whispering to each other about how they may be witnessing the biggest discovery of their lives. But the story does not belong only to NASA or to major observatories. In backyards across the world, amateur astronomers have pointed small telescopes skyward, programming cameras to snap exposures every few minutes. In rural towns, families gather around screens, watching live streams where a single pixel of light is all that matters. Some of these volunteers know their equipment cannot compete with billion-dollar facilities, yet they participate anyway. For them, it is not about being first, it is about being part of something larger than themselves. On online forums, conversations stretch through the night. Enthusiasts share grainy images, compare brightness levels, and speculate wildly about what each flicker means. In these threads, science becomes communal. A retired teacher in Texas trades notes with a student in India. An amateur in Morocco uploads a chart, and within minutes, it is analyzed by someone in Poland. Together, they weave a global tapestry of curiosity, proving that discovery is not the property of one nation or one institution, but of all who dare to look up. Then there are the scientists who never expected to be at the center of such a storm. A graduate student tasked with cataloging light curves suddenly finds their work quoted on international news. A mid-level researcher, once focused on the chemistry of comet tails, now fields calls from journalists asking whether Atlas might be a machine. These people are caught between wonder and responsibility, aware that their cautious words could shape public imagination for decades. And perhaps most poignantly, there are those who stand outside the science altogether, farmers, workers, children, who step out into the night and search for the green glow with their naked eyes. They may not see it clearly, but they know it is there, moving silently above them. For a brief moment, the sky feels closer, more alive, and more mysterious. In the end, Atlas is not just a story of data and anomalies. It is a story of people, of sleepless nights, trembling hands, and eyes turned skyward in hope. Whatever Atlas may be, tonight it has united humanity in a rare way, through shared anticipation, shared wonder, and shared humility beneath the endless stars. As dawn approaches, the world waits for clarity. Somewhere beyond the reach of human hands, Atlas continues its silent path, indifferent to the debates, the fears, and the hopes it has ignited. By tomorrow, new data may strip away the mystery or deepen it further. But for now, in this fragile moment of not knowing, humanity stands on the edge of possibility. Perhaps Atlas is nothing more than stone and ice, a wandering relic from a forgotten system, carrying within it the cold memory of stars long gone. If so, it is still a messenger, proof that the universe delivers its secrets one fragment at a time, urging us to listen closely. Or perhaps Atlas is something else, a beacon, an artifact, a silent scout. If that is true, then tonight is not just another night of astronomy. It is a threshold in history. It means we are no longer the only ones who have reached across the void. But maybe the greatest meaning lies not in the answer, but in the question itself. For in asking, in wondering, in daring to connect the dots, we reveal what it means to be human, to search, to doubt, to imagine. Atlas may pass into the darkness, never to return, but the questions it leaves behind will remain, guiding us to look upward with sharper eyes and deeper humility. And so, the story closes not with certainty, but with invitation. Tomorrow the world may wake to headlines, to confirmation, to revelation. But tonight, as you lift your gaze, remember this. Whether Atlas is rock or relic or something we cannot yet name, the universe is speaking. The only question is, are we ready to listen?